Today we are going to discuss another aspect of solution. We will discuss concentration of solution, different ways to express concentration. So the objective for today's lesson, we should be able to solve problems involving the molarity of a solution, describe the effect of dilution on the total moles of solute in solution. We will define what is meant by percent by volume and percent by mass. When you look at those two solutions, what would be the difference between each one of them? One of them is more what? Look at. One of them is more saturated. I heard you, Lul says one of them is more concentrated. What is concentration? Yes. Amount of the solute that can dissolve in a certain amount of solvent at a certain temperature. Okay, the concentration is how much solute do you have in that solution. Now, there are three different ways to qualitatively describe solutions, and we discussed it in the last lesson. The three qualitative ways to describe the concentration of a solution is unsaturated, saturated, and supersaturated. Those are qualitative ways. Okay, they don't have any measurement, no number. Now, today we are going to discuss, even though you see 4 boxes, but I'm going to discuss 7 different ways to quantitatively measure concentration. Let me repeat. You are going to make a concept map. We are going to discuss 7 different ways to quantitatively measure concentration. Okay, let's start with the first one. The first one is molarity with an R. Molarity is a measurement of the moles of solute per liter solution. It is big M. The symbol for molarity is big M. The unit for molarity is big M. I need for you to really take note of that. Okay? Big M is the unit. Big M is the symbol for molarity. Another way we will describe concentration is molarity with an L. The symbol for molarity is lowercase m. I know you already use m for mass. Okay? The unit for molarity is lowercase m. Sometimes you will see molar, but I need for you, for your work, you can use lowercase m for the symbol and for the unit. Now, I'm going to split this into 2, so listen carefully. A third one is percent by mass. Another way to express, to calculate, to measure concentration is percent by mass. A fourth way is percent by volume. Okay, percent by volume. And we will discuss the formula for each one. I don't want to confuse you too much because today we are just going to concentrate on molarity. Okay, next week, next block period, you will have a quiz on at least 2 of them. Okay, next week I will let you know which one. Question is the difference between molarity and molarity. I did not want to give you the formulas now for all of them, but let me tell you the formula and you will see the difference. Molarity with a big M is moles of solute per liter solution, and molarity is temperature dependent. Molarity, lowercase m, is moles of solute per kilogram of solvent. It is not temperature dependent. Okay, so another way we can express concentration is mole fraction. Mole fraction. So we already discussed 5 different ways. I'm going to add 2 more. I need for you to add part per million, ppm, part per million. Another way, we will also express concentration by part per billion, ppb. Okay, so we are going to concentrate on one of them today. Now, if you come to the lab and I ask you to make 1 molar solution, this is what you do. You measure 1 mole of your solute. Okay, in order to make a 1 molar solution, you must first add 1 mole of your solute. You add that 1 mole of your solute in we call it a volumetric flask because it is more accurate than a graduated cylinder. You put it in your container and you add enough water to make exactly 1 liter of your total solution. Remember, I did not say to add 1 liter of water. I said to add enough water to make exactly 1 liter of your solution. Okay, so you stir it, and this is how you make 1 molar. This is the formula for molarity, big M. It is moles of solute over liter solution. I need for you to add the word solute in the formula. And I need for you to add the word solution for the volume. It is not the solvent. It is the liter of the solution. Mole solute over liter solution. And I said, even though you see moles per liter, I want you to use the symbol and the unit big M for molarity. Okay, now let's do some practice. Let me continue right here. So I need for you to get your calculator ready for me, please. Okay, let's start. IV solutions are often administered to patients in the hospital. 1 saline solution contains, let me highlight. My highlighter here. Okay, so this is our given. This is our given. In exactly 100 ml solution, what is the molarity? They ask for molarity. Question mark. They give me 0.90 grams of NaCl and they give me 100 ml solution and they ask me for molarity. The first thing I will write down on my paper is, what is it? Okay, I would write my formula. Okay, so I would write molarity equal what? Moles of solute, mole solute over liter solution, subscript SOLN. Therefore, molarity equal, what is the moles of my solute? What is the moles of my solute? Do I have the moles of the solute? Do I have it? No, I don't. So I need to go and find the moles of the solute. How do I find the moles of the solute? It is, I have to use the grams. If you can get your periodic table packet, periodic table please, and calculator. Okay, and then we will always go to 100 place. So let's write down our given, which is 0.90 grams NaCl, which is my solute. I use conversion factor. I'm going to write grams NaCl down here. On top I write down moles NaCl. Up here I write 1 mole NaCl and the molar mass is 58.44. Cancel out gram sodium chloride, and my moles is, what is the moles? 0.015 moles NaCl. And I will come down up here and I replace it by the moles of NaCl, which is 0.015 moles NaCl over what? Over what? Is it over 21? Over what? Yes, because this is a milliliter. The formula said to use liter. So I need to divide my milliliter by 1000 to change it to liter. It is 0.1 liter. So therefore, the molarity equal what? 0.15 what? Mole per liter, but I want you, that's fine, moles per liter. I want you to use big M for molar. M-O-L-A-R, molar. Now, how many significant figure in this number right here? How many? How many significant figure in 0.90? 2. How many significant, let me put it 2 here, 2 SF. How many significant figure in 100 ml? It is 1. So household laundry bleach is a dilute aqueous solution of sodium hypochlorite. Okay, and they asked me how many moles? How many moles? Question mark. And then they give me, this is my given, they give me 1.5 liter of 0.70 molar sodium hypochlorite. What do they ask for? How do I find moles? Okay, so let me write down the standard formula. So we know molarity equal mole solute over liter solution. But they ask me for moles. They ask for moles. So if I cross multiply, mole solute, therefore mole solute equal molarity times liter. Mole solute equal molarity times liter. Therefore, mole solute equal, what is the molarity? It is 0.70 molar sodium hypochlorite times, did I say times? Times. The liter is 1.5 liter. So what is the answer? Okay, they asked me for moles. Mole solute. In this case, is sodium hypochlorite. Equal what? 1.05. What is the unit? Moles. The symbol for moles is MOL. How many milliliter? This is our last problem. Okay? How many milliliter of aqueous 2.00 molar? Let me underline my given. This is one of my given. How many sig fig here? It is 3. 3 sig fig. Solution must be diluted with water to prepare. Oh, this is a different type of problem. It is a different type. It is dilution. Okay, diluted with water to prepare 100 ml of an aqueous solution of 0.40 molar magnesium sulfate. I need for you to write that formula down for dilution whenever you are diluting. What is the formula for moles? Okay, symbol for moles. In moles, we are getting a concentrated solution. We are making a diluted solution. But the number of moles of the solute is the same in both. I need for you to think about it. You are taking a certain number of moles of a concentrated solution, put it in a container, add water, but both of them have the same number of moles of that solute. Is that right? Does it make sense? Okay, what is the formula for that moles using molarity? Molarity of the concentrated solution times liter of the concentrated solution. Concentrated. We said they are equal. Equal molarity of the diluted solution times the volume of the diluted solution. Let's read. How many milliliter of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare? What do you think that 100 ml is? Is that the diluted solution or the concentrated? Is that the diluted or the concentrated? It is diluted. Okay, so we write V diluted. How about this one? Is that the diluted or the concentrated? Okay, diluted. So I write down the molarity diluted. What is 2 molar? It is my concentrated. Is that right? And then they are asking me for, what am I solving for? Milliliter. It is V concentrated equal M diluted times V diluted over M concentrated. Therefore, V concentrated equal M, what is that my M diluted? It is 0.400 molar times my V diluted is, now yes, as long as you keep the same unit for your volume, you don't have to convert it back. Do you understand? So I can use 100.0 ml over my molar concentrated is 2.0 molar. Can you give us the answer so I can stop right now? Okay, so my V concentrated equal V concentrated equal 20 ml. So this is the amount of the concentrated solution I should measure and put in a container and bring it up to a total volume of 100 ml. Okay, so we will stop right now for the video with the video.